And you might be wondering what's happening when you take out the letter z and replace it with the letter t in this formula. What you're really doing is just adjusting the z-score. You're really just raising the z-score to a higher number. And when you do that adjustment and you raise the z-score to a higher number, it changes to the letter t. So the letter t is just the adjusted value, meaning you've taken the z-score and you've raised it to a higher number, and now it's called t. And what's the reason for doing this adjustment in which you raise the z-score to a higher number? You're doing this adjustment because of the fact that you're replacing the population standard deviation right here with the sample standard deviation. When you replace the population standard deviation with the standard deviation of your sample, you risk throwing off the margin of error. And if you throw off the margin of error, what can happen is that your confidence interval will no longer include the population mean. So by substituting the population standard deviation with the sample standard deviation, you're risking the possibility of throwing off the margin of error and making the confidence interval end up being too narrow, and the confidence interval no longer including the population mean. And in order to deal with that risk, what you do is you make the entire confidence interval wider so that the confidence interval is more likely to include the population mean. Because if you make the confidence interval wider, the confidence interval is more likely to cross over the population mean at the center. And the way that you make the entire confidence interval wider is by raising the z-score to a higher number. And when you raise the z-score up to a higher number, the entire margin of error becomes larger, and you're adding and subtracting by a larger number, which makes the confidence interval wider. And when the confidence interval is wider, the confidence interval is more likely to include the population mean.